Today we're prepared for a quantitative and a qualitative analysis. Here are some sentence starters that will help you with the qualitative part. Pause the video and check these out. So we're launching this projectile at a 30-degree angle and a velocity of 20 meters per second. Those are the initial conditions that Cam gave us. We're going to take that same projectile, we're going to paste it over here, but we're going to change the angle from a 30 to a 60-degree angle. Here's kind of a key to our video. Everything I do that involves vertical velocities, I'm going to try to write in red, and horizontal velocities will be in blue. And the thing they have in common is their time will be the same. So anything that's neither vertical nor horizontal, we'll put that in green. Step one, we're going to find the horizontal and the vertical components of this projectile, of both projectiles. Next, we're going to find the time spent going up and coming down. And finally, we'll combine steps 1 and 2 to find this horizontal distance, or what we call the range. All right, so I made myself a little note over here with some of the initial conditions and the trigonometry we're going to use to solve this. We have an initial velocity of 20 right here. That's this side of the triangle, so we can memorize these triangles and know that they have a ratio of 1 to 2 to root 3, or we can go through the trigonometry. Let's solve this for the opposite side over here, and then we'll solve it for the adjacent side over here. All right, so solving this, we have the sine of 30 degrees, and that's going to equal the opposite side over the hypotenuse, which is a known of 20 meters per second. We're going to multiply both sides by 20 to get rid of the 20 meters per second. On that side, we have 20 meters per second times sine of 30. That's going to equal the opposite side over here, 20 meters per second times sine of 30. So this is 0.5, which means that it should be 10 meters per second, which is what we got earlier from our memorized proportions of a 30, 60, 90 triangle. That means when it's launched, its vertical velocity will be 10 meters per second, and it's going to slowly lose that velocity. Switching over to this side over here, we know we're going to have the cosine of 30 degrees is going to equal the adjacent over the hypotenuse. So we multiply both sides by the hypotenuse, and that cancels out hypotenuse. So the hypotenuse times the cosine of 30 degrees equals the adjacent side that we care about over here. The hypotenuse is 20 meters per second. Is 0.866. And so that means the adjacent, or our horizontal velocity, is going to be 17.3 meters per second. All right, so we've finished step 1. We found the horizontal and the vertical components. Now let's take the time that it's going to spend going up. We only need to consider the vertical velocity in this case. Switching back to red, the velocity equals acceleration times time. Acceleration is due to gravity. We're going to call that 10 meters, or negative 10 meters per second squared, and a velocity of 10 meters per second times 10 meters per second squared is going to give us a time of 1 second. So it's going to spend 1 second going up and 1 second going down. That means the total flight time, the variable that they share, is going to be 2 seconds. So remember, this is a shared variable. Both the horizontal action and the vertical action both need to be using 2 seconds. Our third and final step, we're going to combine this to find the horizontal distance. Remember, we're only halfway through. This is for the triangle that is a 30-degree angle when launched. And so part 3, this is part 2, part 3, we're combining this with green, 2 seconds of flight time. Our formula is speed is distance over time. That's our triangle. Sorry, this should all be in blue. This is all horizontal. So we have a distance that is unknown. We have a speed that is given from part 1 of the solution of 17.3 meters per second times 2 seconds. That's going to equal 34.6 meters in the horizontal or delta X displacement. All right, so this is before we were launching at a 30-degree angle, 20 meters per second was the initial velocity, and now we're launching the same projectile at a 60-degree angle. Initial velocity is still 20 meters per second. Part 1, break down the horizontal velocity and the vertical velocity. Step 2, find out how much time it spends going up and going down on its parabolic journey. And step 3, find out the delta X, how far does it go? That's what we call the range. All right, step 1, we're going to find the vertical velocity. So let's zoom in on that. The vertical velocity is going to be this part here, and in this case we're going off the 60-degree angle, so it's going to be the opposite side, and this is still going to be the hypotenuse over here. So a sine of 60 degrees is going to equal the opposite over the hypotenuse, or hypotenuse, the sine of 60 degrees is going to equal that opposite side that we need for the vertical velocity. Hypotenuse is 20 meters per second. The sine of 60 we shouldn't be surprised to find out is the same as the cosine of 30, so it's going to be 0.866, giving us the velocity of 17.3 meters per second. All right, let's rewind a little bit and look at why these numbers look so familiar. We're zooming out, we're rewinding back to where we were before, and here's our previous portion of this when we fired the same thing, 30-degree angle, 20 meters per second. Our adjacent was cosine 30. It came out to be 0.866, 17.3 meters per second. All we did was just turn the triangle in a different orientation, and those same values show up again here. So we already know what this is going to be from before, but we're going to solve it just to make sure it's crystal clear. So we need to find the horizontal velocity. It's going to be the cosine of 60 is going to be the adjacent over the hypotenuse And so we need to get the cosine of 60 degrees. That's going to be the adjacent over the hypotenuse, meaning that the velocity we need in the x direction is going to be the hypotenuse, which is the initial launch angle, the initial launch velocity. That's going to be cosine of 60 degrees. And so we needed 20 meters per second, and the cosine of 60 degrees is going to be 0.5, just like the sine of 30 degrees. So the velocity in the x direction will be 10 meters per second. Remember, step 2 is to figure out how long does it spend in the air. So the vertical velocity in the y direction initial is 17.3 meters per second when it's shot at a 60-degree angle above the horizontal. So how long does it spend in the air? That depends on how long does acceleration and time, acceleration of gravity, allow it to stay there. That's 17.3 meters per second equals a negative 10 meters per second squared times time. So the time that it spends going up is going to be 1.73 seconds, and the time it goes down also going to be 1.73 seconds, for a total of 3.46 seconds. Coming back over to the horizontal side, we need to know the distance that it's going to travel based on the speed times the time. And so now we have a time from over here that we bring over to that side, and we have a speed from right up here that we bring down from part 1. So 10 meters per second times 3.46 seconds is going to equal a delta x of 34.6 meters. And again, if we zoom out and rewind a little bit, our quantitative and our qualitative analysis is done because we've shown that the range is identical regardless of whether you shoot it at a 30-degree angle or a 60-degree angle. You manage to get the same distance covered.